David. This is my COP 2800 final project using IntelliJ IDE. I created a 2D game reminiscent of asteroids, or more, my inspiration was more sort of um, Geometry Wars, which is no longer available on the iOS App Store for some reason. I remember I used to play the game a lot, and I got the inspiration off of the 2D mode that they provided for that game. It was a fun little game side mode. So I decided to replicate that here using Java. When I first started on this project back in January, I was intending on using the JMonkey engine, uh, Java engine, so that I could create a 2D plane and have the different sort of imports and the different libraries that JMonkey Engine uses. Since I was using that to create a bunch of other 3D programs, which was just me making imports on Blender and then exporting and so forth. That was pretty self-explanatory. But when came to actually making the logic, I ran into a bunch of different issues to the point where I wasted sort of 2.5 months just trying to get things to work when it just flat out came calling myself because my logic was bad and I had to redo the project a bunch of times. So because of just the difficulty of me getting into JMonkey Engine and how expansive and sort of big of a engine it can be, I decided to sort of make something that was a little more understandable and easier to sort of implement. So it's where we are how now. The main class, obviously, right here. This is what starts up the game. We have the public static game panel, which extends off um, of the import for game paneling, game window, and I do use Swing here and there for the JFrame panels, but most of this game is built off of AWT, which let's see if I can scroll right here, was a good handful to sort of look out. But this is pretty good for graphics and just displaying images and having those images interact, the different collisions. It was pretty self-explanatory. Before I go into the actual game logic, I'd like to show you the different extensions that we have, starting with game object. This right here creates different floats for the size, the image, the opacity, the rotation and speed, and all the other things that I will need whenever I'm expanding this with the player and with the enemy. Buffered image, you'll see another class here where I basically went and looked out how I could use images and then transfer it over, which is where the wonderful help for the Java buffered image class, which I really liked it because it helped me apply the coordinates and just sort of get how that was working, get that working. With the buffered image, we were able to import all the images for the game, including the background, the player, the bullet itself, all different enemies that are available in the game. With the load image, this was so that I can sort of have the file to load, and that's all in this buffered image class, which goes back into the game object. So the game object gets the the thing to display the image. And then from there we can sort of apply the different this game object class to all the other things I need. So in this game you have the player, that's right here, which extends off of the game object. You have a vector for velocity, the bullets that it shoots. You have a boolean whether it shoots, the cooldown. Down here we have um, some of the formulas on how the player's position, and whenever they move out of the screen, they would just pop out from the other side. Um, based off of this, this shoot is what allows us to sort of shoot, and we have a cool little sound animation that flies. And again, we have the more of the formula of how that works. For example, the float dx and float dy, we have a direction with the x, and then we multiply that by the width. But the width is divided by 4. I had a great friend of mine who sort of taught me how exactly I would have to set this equation up on whether you know on having the shooting ability while you move. So that's enough about the player. If you go on to enemy, we have the base enemy, which I believe this one, yeah, this one doesn't do anything. This is just the this pulls from game object, and then we can have the X, Y, size, image, so on and so forth. We have 3 sorts of enemies that the player can interact with. We have the slide enemy, the spike enemy, the tracker enemy. They're all based off this class right here, but they extend on it even further. So we'll start with the slide enemy first. Slide enemy first extends enemy. We have the same vector with velocity. I believe this one is set so that it doesn't move. No, I'm sorry. Slide enemy is the one that goes in one specific direction. So um with this one, actually, I'll probably go to this one first because this one is the one that doesn't do anything. So this one gets load in. We have the float x, y. It's imported. The rotation, we have a float that makes it rotate ever so slightly so that it'll slowly just spin in a circle, and then the rotate function will appear here. If the opacity less than 1, we have opacity plus or minus +3, so that makes it I think that makes it spin faster, I believe. And then if the opacity is 1, opacity equals 1, which I believe this gets rid of the this gets rid of the enemy once you defeat it, which will be in the main sort of game. The next one on the slide enemy, this one is the same thing as the first one, but we have a speed that's set and a random rotation, which is what we use to spawn it at random. We have the math.random method, and then we have the formula on how the rotation would work. Then the velocity just basically grabs this and calculates it for see how fast it's going, and we would have the this would allow us to get the what's the word? This basically allows us to be able to, once it's off the screen, to remove it. So that's where this comes in. We have the opacity, of course, and then if this function were to work, the remove flag, which is the thing that I use so that it gets removed, equals true. This is also whenever the player does eliminate it, but if it goes off screen, it's already dead. So we would perform this command. Otherwise, the same thing as the regular spike enemy. Now we have tracker enemy. So this tracker enemy uses a target, which the target would be attached to the player. With the opacity, we use this equation right here to sort of create a force where the enemy would just sort of follow the player nonstop until they perform the collision. We have the velocity formulas on how this would react compared to the player. So the player would move in a certain direction, then it would react and move along with the other reaction. Otherwise, it's the exact same thing as the other class. These are all the enemies that are in the game. They all work different, but if the player were to touch any of them, that removes one of the lives off of them. So we'll talk about that once we get to the actual main game. Bullet. The bullet very 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 difficult to implement. I had no idea how I wanted to set it up. And when I first started making it, I was using fully transparent um, models, PNG sprites, which looked wonky. So it was just a whole bunch of just trying to get it to work, trying to get the collisions to sort of perform. And this is the I made it so that the bullets are a lot faster because in the 720p by 1280 display that the window that pops up, it is very small. So having shorter bullets or slower bullets would have made it the game a lot more difficult to sort of play with in terms of pace. So this just grabs the velocity and this and the multiplies it by the speed. It gets to the x and y variables on where it's at, and then that's what moves the bullet across the panel. This is just all based off of game object. Again, the game object grabs the images, creates sort of a class and a method that you can where you can just grab all these and then implement them into each one specifically. I believe, yeah, game panel and game window. Game window has the Java swing, which extends the JFrame and allows us to sort of open up the game and get the game window. So we import Java X.swing. This was mainly just me scrolling to Stack Overflow and getting it to sort of finding a way to implement game window into that Java swing. Game panel, I believe, is just more of the same. We have what do inputs we have? I forgot. We have the main.game, which starts the game, and then yeah, Java.swing, and then Java AWT. The dimensions grab it from the width and constant, which are public static final ints for the width and height. Which this is actually I don't know where was this at. I think this was in the game. Was it? Is this in the? Was it in the game so that I can get the? No, no, it was in controls, I believe. Um, to get the. No, it was in constants. My bad. So I think I talked about constants already. If not, constants. We get the final ints for the hit, the width, height, FPS, all that. This changes the game dramatically. I believe I had to just look into res resolutions screen, and then it gives you just a bunch of different ones. Um, I tried originally 1980 by 1080, and it worked, but it was just so choppy. Even though the FPS was at 60 FPS, I think it was because the way the screen and the pixels multiply. I don't have anti-aliasing on this, which was just a pain because my models again were very high quality at first, so it just didn't render right. It looked ugly, so I had to sort of turn it down to 1280 by 720p, which looks fine. Um, I believe I was in the game panel, which it grabs the dimensions and then sets it, and then we use swing for that. Controls. This I had watched a very great video on how to make a sort of 2D game where you walk around that allows us to in that video the guy he made it just a game where it was like the character can move in four directions, but it was more sort of like a top down game like a Zelda or a Pokemon. But that was very helpful for me to get the controls and movement to work. So finally onto the game itself. Game thread. Game thread. I believe I had a friend recommend it to me, and if I go ahead and look up game thread, I think I have it in. Uh, uh, I forgot I forgot the game how I implemented the game thread. Um, the players implemented, enemies are implemented, the spawn time is implemented as an int on how many they spawn. This changes based on the difficulty. Of course, int difficulty is another implementation that I made. Um, we implement a new player. new enemies and new spawn times, and the spawn times are dependent on the difficulty. So this constant enemy spawn times inherits the difficulty. The score, it starts at 0, but it's always counting up, and I'll show you that later. Lives, we only have 3 lives. I can always add more, but with 3 lives, it's just the classic for normal retro games. And then we have the bool for the game over, so that we can change difficulty. When you start up the game, you're immediately booted into the easiest mode. Once you die, we have a menu that we use so that we can sort of pick what difficulty we want, and that'll alter this restart so that the player and the radius remain the same, but the spawn times change and the amount also changes based on the difficulty int number. Initialization, this just starts the game, and we have the play sound method, which I just picked a random song that I thought would fit nice, and then I just stole the audio from a free audio website. I think it was I don't remember what it was. It was like people that like they make audios for free, and they just like upload like random audio of anything, and I just took it from there. With the game over, with the bool, if the bool is false, we have the bool allow, so that we can hit bullets, and then enemies start spawning into the display itself, and the player also draws in the display. And then we have draw UI, so that everything just loads in all at once. We have the remove flagged class that I believe I already discussed, that it removes the enemies, and then this thing spawns enemies, and then depending on what class method is being iterated, that'll sort of, depending on whether it's a game over or if we're in the middle of a game, that'll just load in both, and then both methods will be loaded in with the whatever code is in it. Let me see if I can. We have these ints that I showed you before, and of course they are run by the buffered image with the background image. This right here was very graciously given to me. I was giving him the code. I'm like, hey, I wanted to figure out how I could make different game modes, and these all different things are show up at the end of the game whenever you finish, and then they're centered. They have like the perfect font. They look really nice. We have spawn enemies. If the spawning time is less than 0, these floats perform random math, so that the enemies have a place to spawn, and that changes randomly. So you'll see the enemies are just spawning randomly, and this also changes depending on how many spawn. If less spawn per how many frames there are, then this is the same thing, but less will start spawning in. This is the way that I implemented for different enemies to spawn. So if the type of enemy is less than 0.4, like we had their rotation was less than 0.03, then we have a new enemy. Else, if that's already spawned in, then we have a new the slide enemy, and then if that's not spawned in, then we have a new spike enemy, and this just starts looping again depending on what state of the game we're in. This just adds enemies in, and then here we have the remove flagged. This is so that the enemies get removed. So depending on whether they're out of the screen or if they get hit by the bullet, this for loop iterates through it, and then this other if statement checks to see if the enemy is already removed. If not, then for whatever time that the player hits it, then the bullets collide with the enemies, and then it gets removed. Um, this is just an extension of this. The collision checks to see if the enemies um are near each other, and then if the enemies touch, the enemy dot remove flag and this are all true, the bools become true, and then I play a explosion, little sound, and then the score adds. So this score implements, and that's how we check the score. So if you checked up here, we had a constant score that was looping, and the score is centered, so you can see it in the top part of the screen, and then that just adds for every enemy that is a collision. This eliminates the enemy from the screen, and then this adds you the score for whatever however many times this loop runs. So um, this, I believe, was so that we could save the score near the end. So other than that, I believe that's pretty much it. There's probably more to discuss with how the equations were set up. I did a lot of debugging with how the enemy spawned in and how I wanted to interact with him. But let's take a look at the game and see how it runs. So this is the easiest difficulty. The unfortunately, um, because I use the sort of top-down perspective for this, it sort of just moves like four directions. I could probably get it more diagonal if I were to update and do more research on how I can fix the rotation. But let me just go ahead and lose my lives so I can show you the game over screen. Game over screen loads. We have R to restart, and using the arrow keys we can sort of siphon through the difficulties. Let me show you the hardest one so that you can sort of see how, depending on the 60 frames, how many enemies spawn within that time frame. It's quite a bit. So something that I decided to add was that the first sprite sheet, the one that just rotates, those are gonna stay there, and they don't move until the player hits it with a bullet and the bullet collide. Then we have the remove flag method. Otherwise, they'll stay there until you either bump it to them or you hit them. So if I were to bump into one right now, it gets eliminated because there is the collision there. But otherwise, it doesn't. It just stays there. With the trackers, with the tracker ones, those also get eliminated when they collide with you, but they're much faster than the main player due to the speed being altered. And then I believe the meteorite type, that one is the one that's they're both the same difficulty. They're both 20 speed, but the other one just has a random collection, has a random rotation, and it just moves randomly in one straight pattern. So there's the method for where I sort of can cross the screen and then go all through the side. This is actually a pretty good strategy. Just going straight. Oh man. So there is three sounds that I use. We have the shooting sound, the explosion whenever the collision occurs and they hit each other, and then of course the music. So yeah, that was my project. Thank you.